Hi, welcome to Educator.com. We're going to talk about the chi-square test of homogeneity. Previously, we talked about the chi-square goodness of fit test. Now we're going to contrast that with this new test. It's still a chi-square test, but it's a test of homogeneity now. We're going to try and figure out when do we use which test. Because we're testing a new idea, we're not testing goodness of fit, we're actually testing homogeneity, similarness. We're actually going to have slightly different null hypotheses and null and alternative hypotheses. So we're going to talk about how those have changed. Then we're going to go over the chi-square statistic, and also finding the expected values is going to be a little bit different in tests of homogeneity. Finally, we're going to go through chi-square distributions as well as degrees of freedom and the conditions for the test of homogeneity. When can you actually conduct this test sort of statistically legally? Okay, so the first thing is, what is the difference between the test of homogeneity and the test of goodness of fit? Well, remember in the goodness of fit hypothesis testing, we wanted to determine whether sample proportions are very different from hypothesized population proportions. One way you could think about this is that you have one sample and you're comparing it to some hypothetical population. In tests of homogeneity, and that's why it's called goodness of fit. It's about how well these two things fit together. How well does the sample fit with the hypothesized proportions? In tests of homogeneity, homogeneous means similar, right? That they're made up of the same stuff. In tests of homogeneity, we want to determine whether two populations that are sorted into categories share the same proportions or not, right? And here you could also substitute this word population here, because ultimately we're using the sample as a proxy for the population, right? So here we have two populations, and we want to know whether those two populations are similar in their proportions or not, right? We're not comparing them to some hypothesized population. We're comparing them to each other. And so really, you could think of this as an analogy. You could think of their relationship by using an analogy from the one sample to the independent samples t-test. In the one sample t-test, we had one sample and we compared it to the null hypothesis, right? That was when we would have null hypotheses such as mu equals 0, or mu equals 200, or mu equals -5, right? Versus in independent samples, we had two samples, and we wanted to know how similar they were to each other, right? Or how different they were from each other. And our null hypothesis was changed to something like mu sub x bar minus y bar equals 0, right? That they're either made up of the same mean or different means, right? And in a similar way, the goodness of fit chi-square is really asking whether this proportion in my sample, I'll just use black and white, right, is similar to the proportion in our population, right? So that's how I'm comparing it. This is my null hypothesis in some ways. In our test of homogeneity, we have two samples, two populations, two samples that come from two unknown populations, right? And we want to know whether these have similar proportions to each other. And so that's going to be our null hypothesis, that these have the same proportions or have different ones. So our null hypothesis is similar proportions. All right. And so in that way, I hope you could see that goodness of fit and homogeneity, they're ideas that we've looked at before, comparing one sample to a hypothesized population or comparing two samples to each other. But we've looked at it before, not with proportions, but with means, right? And now we're looking at it with proportions.